Hey everyone, welcome to Unit 12. We're going to be starting out with 12.1 vertical parabolas in vertex form. Good thing about this chapter, it starts off with parabolas, which you already know how to graph. So for the graphing part, 1a, 3a, 5a, finding the vertex, going to be pretty similar to what we've done in the past, so that will be good. First of all, what is a parabola? Basically, it's a collection of points that are a distance, that is a fixed distance from a point, which we're going to call a focus, and a line, which is called the directrix. Okay, I linked this Desmos little guy here so that you could see what's going on. Okay, so here is what's happening. And these two lines right here, this green and yellow, or the orange line, just ignore that. But we have a red parabola. Okay, we have this vertex, okay, at 0, 0. And basically what happens is as I move along here, you'll notice that the green and orange lines are exactly the same length, okay, because the focus and directrix are equidistant from any point on the parabola. The directrix is this orange line. The focus is that green point. Okay, and I want to change up a few things. So what if I move the focus closer? Notice what's happening to the directrix. They're both 2 units away from the vertex. And then if I were to flip it over, I want you to notice where is the focus. The focus is always inside of the parabola. So if it's facing upside down, the focus is inside the parabola, and the directrix is on the outside. So notice the directrix never crosses the parabola. So again, I'll move it up here. Focus is on the inside, directrix is on the outside, and they are exactly equidistant apart. Okay, and we'll talk about how this changes, but like this distance, okay, let's say we're right here and the distance is about 2 away from the vertex. That's going to be called our P value, the letter P. Okay, so if you go back to our notes here, okay, you'll see something you've seen before, which is this equation right here. Y equals A times X minus H squared plus K. This is called vertex form. And you'll also notice that instead of A, we could have it as 1 over 4P. Now we're going to still call it A, but this brings up an important equation. A equals 1 over 4P. So write that down. So what's going to be happening, like I mentioned, okay, P is the distance from the vertex to focus and vertex to directrix. So again, it's that little distance between focus to vertex and vertex to directrix. And once we graph these, I think you guys will get it down a little better. Okay, so we're just gonna be working with vertical today. We'll come back to horizontal in a couple days. So just stay on the left side for now. What is the vertex? The vertex is H, comma, K. Remember, you take kind of the opposite of the X value there. The axis of symmetry, it goes right down the middle. So if we're at HK, it goes right through H. So X equals H is a vertical line. It's that axis of symmetry. Where is it symmetric? How do we know if it opens up or down? Okay, if A is positive, or if A is greater than 0, it opens up. And if A is less than 0, it opens down. That should be review. Okay, and then last 2 things here. These are these 2 new words. Focus, okay, it's a point inside the parabola. And a directrix is a line outside of a parabola. And again, if you click on that Desmos demo, it is that green dot and orange line that are, maybe it was a purple dot, sorry, I don't remember. But anyways, it's those 2 pieces that are extra to our parabola. How do we find it? Well, if it's a point, it's going to be at the same thing as the vertex, but the Y value is going to shift up or down by P. So it's either going to look like that, or it's going to look like this. And again, I don't really use the equation, I usually just visualize, so stay with me here. And then a directrix, if I were to draw it in, I've got my focus, and my directrix would be below the vertex, or I draw on my focus, and it would be above. Okay, and that's going to be what it looks like. So it's a horizontal line at our K value, which is our vertex. We're going to move up or down P. which is, again, P is that distance from the vertex to the focus or the vertex to the directrix. Okay, so let's try graphing this. I think if I asked you last week to graph this, I hope your answer would be, yep, I know how to do that, because we just did this with inequalities. So let's try it out, guys. What is the vertex? The vertex is +1, +3. Again, opposite inside, regular out here. How do we know which way it opens? It opens up, or you could draw a little shape, because a value is positive. The a value is 2. So what's the p value? Well, remember, we have this little equation here, a equals 1 over 4p. You should definitely memorize that, / have it in your notes. Okay, so we're gonna just do this little equation. So we have a is 2, 2 equals 1 over 4p. Solve for p. I cross multiply, 8p equals 1, so p is 1/8. You're gonna get fractions a lot. That shouldn't be super surprising, so don't be alarmed. And then let's find the axis of symmetry. Axis of symmetry is pretty easy because it's always whatever, in this case for a vertical, it's whatever the x value is. It's gonna be x equals 1. And it's an equation of a vertical line, so you wanna put x equals. So let's try graphing this, guys. Remember, for our a value, whatever our a value is, parabolas go in a 1a, 3a, 5a pattern. So in this case, instead of 1, 3, 5, it's gonna go 1 times 2, 3 times 2, 5 times 2. So it's gonna go in a 2, 6, 10 pattern going up. So we go to our vertex, 1, 3. We go up 2 over 1. Oh. And then we'd be going up 6 over 1. So, whoops, doesn't really fit. Try to make it as best as you can. Okay, not my best drawing, but we'll take it. And the reason I didn't do this focus and directrix yet is usually I don't really use an equation. I typically just visualize it because I know where the focus and directrix are going to end up. I also know that they are 1/8 of a unit away from the vertex. So here's what I want you guys to do. Pause it if you need to. If you're done graphing, let's zoom in really, really close here. Look at how poorly I graphed. Okay, so the focus, where is it? It's going to be 1/8 above the vertex, and the directrix is going to be 1/8 below the vertex. And again, why is that? The focus is inside, the directrix is outside. Okay, so where is this focus located? Well, you were at 3 and you went up 1/8. So now we are at 1, 3 and 1/8. Now, anyone who has me as a teacher knows I pretty much hate mixed numbers, but in this case, we'll allow it. Obviously, you could also write 25/8, but I won't make you do that. So 3 and 1/8, and then where would this directrix be at? It's y equals, and it's 3, but you went down 1/8, so it'd be at 2 and 7/8. 3 minus 1/8. That's how I got 2 and 7/8. And that's your answer. So notice it is that k plus or minus p situation, but I usually just visualize it. So 1, 3, 3, and I added 1/8 because I went up for the focus. And then my directrix is y equals 2 and 7/8. And you can use your graph to help you. That's typically what I do. All right, I want to try one more with you guys, graphing. So try example 2 with me, okay? And again, the first part should be pretty straightforward because you know how to graph a parabola technically, just not the focus and directrix. By the way, I kind of forgot, oops. On this graph, I probably should also graph in that axis of symmetry, which is also a dashed line. So your final picture is a parabola. We've got our focus, we've got our directrix, we've got our axis of symmetry. So kind of 4 pieces per parabola. Okay. Anyways, back to this one. So this is in vertex form. Think of it looking like this. That might help you decide what the vertex is. So our vertex is 0, 5. It opens down because we have a negative a value. Our a value is negative 1/2. So we want to know, when is negative 1/2? This is a equals 1 over 4p. So what would our p-value be? Negative 4p equals positive 2, so p equals negative 2 over 4, which is also negative 1/2, which happens. So a is negative 1/2, p is negative 1/2, and then don't forget your axis of symmetry is just whatever that x value is. So x equals 0 will be straight down the middle. All right, so let's try graphing this. And again, pause if you need to. So for our pattern, 1a, 3a, 5a, we're going to be going down 1/2 over 1, down 3/2 over 1, and down 5/2 over 1. And if you don't like that, sorry, that's just kind of how it is. 1/2 is a half, 3/2 is 1.5, and 5/2 is 2.5, so that might help you graph here. So let's try it out. We're at 0, 5. 0, 5, we're going to go down 1/2 over 1, down 1.5 over 1. So we're actually going to end up at a nice point. Down 1.5 over 1. And you could do the last point. I would say you guys need to have 5 points total, so this is fine. Or you could go down 2.5. So down 2.5 over 1 is how I got there for 5/2. Perfect. Okay. Now, last 2 pieces, guys, or 3 pieces, I guess. I'll do it in yellow. The first thing I'm going to do is draw in my axis of symmetry. So I sketch that in. The second piece I'm going to do is my focus and directrix. So focus, okay, how far away are they? Well, it says p is negative 1/2. That's what we figured out. So since p is negative 1/2, that means I'm going to go 1/2 away from the vertex and 1/2 away for the directrix. Notice that the focus is inside, so it went down this time, and the directrix is outside, so it's above. Okay, and let's try to figure out those 2 points, that point and line. So the focus is a point. I was at 5, and I went down a half. So now instead of being at 0, 5, I'm at 0, 4.5. And again, you could write that as 9/2. I don't care, either way. Okay, and then where is the directrix at? It's y equals, it's a horizontal line, y equals, I was at 5 and I went up by a half, so y equals 5.5. So this was at 0, 4.1/2. This was at y equals 5.5. Notice it's a point and this is a line. All right, guys, so that's it for graphing. I want to look at 5, 6, and 7, or 4, 5, and 6 rather. Okay, we're not going to do all of them, but I want to try a couple, and then we'll be done. So example 3 is a great example if you want to try it. I highly encourage it, and it'd be good practice. So example 4, 5, and 6. So what I'm going to try with you guys is which ones? I want to try example 5 and 7. Okay. So write the equation of the parabola. So we want it to look like this. Y equals a times x minus h squared plus k. Write the equation of a parabola. Okay, so here's how we're going to start. First, we're going to do our vertex at 1, negative 4. So that's awesome. We actually already have a lot of information. X minus 1 squared minus 4. Only thing missing, guys, is this a value. Okay, and this 1, negative 5 focus situation should help us out. Okay, here's what I want you to think about. I would actually sketch these. My recommendation, approach this problem, just do a little sketch. So 1, negative 4 is my vertex. 1, negative 4 is like right here, let's say. And then it says my focus is at 1, negative 5. So this is vertex, this is focus. That means that I have to open this way because I want the focus to be inside. So what did I just figure out? I figured out that A has to be negative. I also figured out that the focus, how far away is the focus and the vertex? They are 1 unit away, which means P is 1. Or you could say P is negative 1 since I went down for the focus. Okay, now this is very important because I have a lot of information here and I have this little equation, A equals 1 over 4P. So I'm going to be plugging in. A equals 1 over 4 times negative 1. So A is negative 1/4. Final answer over here, guys. Negative 1/4 times x minus 1 squared minus 4. Okay, so how did I get that? I got that by figuring out that the vertex and the focus right here, this was at 1, -4, this was at 1, -5. These are 1 unit apart, which gives me P is 1. I also know A is negative because the focus was below, so I had to open downwards for the focus to be inside. Okay, and then let's try example 6. Okay, last one here, guys. Example 6 gives me the focus is at -3, 2, and the directrix is at y = 0. Okay, do I have my vertex? No, I wasn't given that. But what I am given is a good piece of information here, which is that I'm just going to sketch, see what's going on. So -3, 2. And you don't have to sketch. It's just kind of a nice way of figuring out what's going on. And then it says our directrix is at y = 0. Okay, and this is our focus. We know that our vertex has to be exactly in between these two things, right? They're equidistant. So if we're at 2 and we're at 0, that means our vertex has to be right here. And where is that vertex at? That's at -3, 1. Okay, we also just figured out something important, which is that because these are 2 away from each other, that means that our vertex is 1 away from our focus and 1 away from our directrix. We also know that it opens up because we want to have the focus inside of our parabola. So now I also know this value right here, P, is 1 because the vertex is 1 away from the focus and 1 away from the directrix. We use our handy equation, A = 1/4 times 1. So A is positive 1/4. That should make sense because it's facing up, so it should be positive. And we have our vertex is -3, 1 because it was directly in between and lined up with the focus and directrix. So let's write our equation. Y = 1/4 times x plus 3 squared, again opposite, plus 1. And there's our final answer. All right, guys, well, that's it for me. Thank you so much for watching, and please email if you have any questions.